All right, AP Environmental. We're going to continue here with Unit 6. I'm going to have a couple different videos for these topics. So I'm going to make one video for geothermal and then one for wind and hydrogen cells. So again, make sure you do watch both of these. So let's kind of start today, just kind of continuing our discussion about renewable sources of energy. And we talked the other day a little bit about solar and about hydroelectric. And in this first video, I want to talk about another renewable energy source called geothermal energy. Now, geothermal is pretty simple. I mean, it's just using heat that's generated from the earth. Within the core of the earth, for example, there are radioactive elements down there, like way, way down in the core of the earth. And these radioactive elements decay, and as they decay, they produce heat. And that heat rises up through the mantle and eventually can make its way up to the crust of the earth. And we can tap into that heat and we can use it for a variety of things. One of the things that we can use it for is heating our homes, heating water, and even generating electricity, which I'll show you in a couple of minutes. One of the limitations to geothermal energy is geography. You know, it's not like every area on the surface of the earth, has the same accessibility to this geothermal heat. Some places it's more accessible than others. One of these places is Iceland. Iceland's kind of an interesting country. There's a ton of volcanic activity there, which means that a lot of that geothermal heat actually makes its way to the surface. Um, 87% of the homes in Iceland are actually heated using geothermal heat. In the U.S., I mean, you probably would be hard pressed to find anybody who heats their home this way, even though there are a lot of people that do. It's just not a real common thing. It's common in different areas of the U.S., but in Iceland, it's a very, very common thing. In the U.S., this picture here is kind of showing you, certain regions where it is more accessible to obtain this geothermal heat. These areas kind of in these darker oranges, especially out west, Utah, Colorado, Nevada, Idaho, these areas, there's a lot of accessible, easily accessible geothermal heat. So you see a lot of that technology being used out here, not so much out here on the eastern coast. In the Midwest, kind of an interesting little pocket right here, Indiana, Illinois, there is some geothermal heat that's fairly accessible. So you do see a little bit of it here, in the Midwest, but a lot of it occurs out here in the western part of the United States. Now, once we can tap into that heat, once we can absorb it, there's several things we could do with it. And again, one of them is to generate electricity. So what you're seeing here in this picture is kind of a common theme that we've seen a lot in the last couple of weeks. As long as you have a turbine that spins, it can operate a generator and produce electricity. The thing is, you need something to spin the turbine. In a coal power plant, we use steam. In a nuclear power plant, we use steam. In a hydroelectric power plant, we use running water. Wind energy, we actually use the wind to spin the turbine. Well, here what we use, we also use steam here, but how the steam is produced is a little bit different. So what we do here, we have what we call an injection well. And what that is it's basically a well where we pump water down it. So this water has to come from like a river or a stream or something, but we pump water down the well. And the further down you go, the more accessible that geothermal heat becomes. So we can tap into that heat, we can heat the water and even boil the water to produce steam, which comes up the other side of the well. And that steam is what can spin the turbine and operate the generator. So, what we're using for the fuel source here is we're using that geothermal heat from inside the earth. We're not burning coal. We're not, producing any greenhouse gases, any of that type of stuff. So, some of the advantages are that there is absolutely no combustion. This is clean energy. There's no carbon emissions whatsoever. It's also an extremely reliable source of energy as long as you have access to it. I mean, the people that live in Iceland, for example, they can use this geothermal heat for thousands and thousands of years. It's not going to go away. They're not going to run out of it. It's not a non-renewable energy resource. Now, some of the disadvantages of geothermal, some of the limitations. It is really expensive, especially if you don't have easy access to it. I mean, like, for example, down in Florida, they don't have very easy access to geothermal heat, but they can still get it. They just have to inject really deep into the Earth's surface. The deeper you go, the more expensive it's going to get. So, for example, some of these areas on the eastern side of the country, they could still access geothermal heat, but it's not very cost prohibitive. I mean, it's going to be really expensive for them to do that. So you don't see them doing that very often. There are dangerous gases that can be emitted. One of these is hydrogen sulfide, which is a component of acid rain. We'll talk about that more down the road. Again, installation is limited by geography. Not everybody has the same access to it. And we do use a lot of water, just to generate the electricity. So that water has to come from somewhere, usually a local lake or a local river. All right, so we'll stop here today with this video. I do want you to watch the next one on wind and, excuse me, and hydrogen fuel cells. All right, guys, have a good day.